Tonight, we uncover the terrifying mathematical evidence that our universe is not a permanent home, but a failing, decommissioned machine struggling to hold itself together. Imagine waking up to find that the very walls of your house are actually just holograms projected onto a crumbling ruin. For centuries, we've trusted our senses, believing that gravity, light, and the very atoms in our bodies are absolute truths of nature, the hard-coded rules of existence. But what if those laws are nothing more than emergency patches, environmental accidents, chosen simply to keep our particular slice of the cosmos from evaporating into nothingness? Recent discoveries in higher dimensional geometry suggest we are living inside a noisy, entropic signal that is rapidly losing its coherence. The stability you feel beneath your feet right now isn't a fundamental property of the universe, it's being forced by a 24-dimensional scaffolding that is starting to creak under the weight of a thinning cosmos. We are the beneficiaries of a system that has already been turned off, wandering through the quiet, cooling embers of a reality that is slowly forgetting how to exist. We have spent our entire history as a species finding comfort in the act of building, believing that the universe itself is an architect that rewards the assembly of parts into something greater. In our simple three-dimensional reality, we see this logic everywhere, in the way atoms cluster into molecules, the way stars huddle into galaxies, and even in the simple, satisfying way we stack oranges at a fruit stand. We assume that the more space we have to work with, the more room there is for complexity, and the more ways there are to arrange the pieces of existence into beautiful, efficient patterns. We look at the stars and see a masterpiece of engineering, assuming that the factory of reality is still running at peak capacity. But as we peel back the layers of higher dimensional geometry, we discover a mathematical threshold that feels like a personal insult to the very concept of life. Deep within the extreme mathematical territory of the 24th dimension, there exists a structure of almost supernatural elegance known as the Leech lattice. It is described by those who study it as a rare island of perfection in an otherwise turbulent and indifferent dimensional sea. While the lower dimensions, the ones we inhabit, are often geometrically messy and difficult to optimize, the 24th dimension provides a moment of absolute, exact certainty. In this space, spheres can be packed together with such incredible efficiency that a single central sphere is touched by exactly 196,560 others. This isn't an approximation or a lucky guess, it is a mathematical constant, a perfect configuration that cannot be improved upon. But the Leech lattice is far more than just a geometric curiosity for mathematicians to ponder. It is the very scaffolding used in our modern world to create error-correcting codes, the invisible math that allows us to recover lost meaning from digital chaos. This raises a question that most physicists are too uncomfortable to ask out loud. Why is a structure from the 24th dimension so perfectly suited to protecting information in our 3D reality? The answer might be the most profound reframing of reality ever proposed. It suggests that higher dimensions are not where physics breaks, but where it is repaired. Perhaps the reason the universe feels stable, the reason information is conserved and the laws of nature don't simply evaporate into the void, is because this deeper geometry refuses to let meaning fully dissolve. We are, in a very literal sense, living inside a noisy channel. In this view, what we call the constants of nature, the strength of gravity or the charge of an electron, are not deep, immutable truths about reality itself. Instead, they are the settings chosen by this underlying 24-dimensional geometry to keep our particular slice of the cosmos from collapsing. The Leech lattice acts as a team of 24D repairmen, constantly patching the holes in our reality, fixing the dropped frames and distorted pixels of our existence before we even notice they're gone. We feel safe because the world around us remains consistent, but that consistency is provisional. We are like passengers on a grand ship who believe the hull is solid, never realizing that 1,000 tiny pumps are working around the clock, hidden beneath the floorboards to keep the water out. We see the stars and assume the factory is still running, but the most unsettling implication of this repair shop theory is that every repair system has a limit. As the universe continues its long, slow expansion into what scientists call the cosmic evening, it is thinning out. As space expands and the distances between galaxies grow, the universe is losing its dimensional context. We are moving toward a state where the signal-to-noise ratio of reality is beginning to drop. When a repair code in a computer starts to fail, you don't necessarily see the whole system crash at once. Instead, you see glitches. You see artifacts in the image, strange delays, and data that no longer adds up. We may be entering an era where the underlying geometry of the universe is becoming corrupt, and the 24D repairman can no longer keep up with the encroaching noise. This would mean that the end of the universe won't be a physical explosion, but a mathematical dissolution. It is the moment the error-correcting code of reality finally gives up. When that happens, the laws of physics themselves would stop being absolute and start behaving like suggestions. We might see regions of space where gravity begins to fluctuate, or where the speed of light is no longer a constant. These wouldn't be miracles or new discoveries, they would be memory errors in the fabric of the cosmos. We are trapped in a dimensional bottleneck, and the only reason our reality hasn't already unravelled is that the scaffolding of higher dimensions is still holding us together. But the scaffolding is beginning to creak. The background hum we hear from the Big Bang, the moduli echoes of that higher state, is not just a memory, it is a reminder that our current reality is just the cooled, collapsed residue of something much more energetic. The 24D repairmen are not gods, and they are not eternal. They are the geometric imperatives of a system that is running out of energy and losing its grip on the structures it once maintained with such supernatural elegance. If reality is indeed responding to a deeper form of knowledge or code, then the question is no longer whether the universe is ending. The question is, how many more errors can the system correct before the static finally takes over? We are witnessing the final accounts of a universe that is effectively closing its doors. And as the lights go out, we are left to wonder if the next glitch we see in the night sky isn't just a distant supernova, but the first sign that the repair process has finally failed, and the hull of our reality is finally starting to let the water in. Tonight we explore the day the greatest mind in human history was proven wrong about the very nature of the ground he stood upon. For your entire life, you have lived with a silent, comforting assumption that the world exists when you aren't looking. You believe that your car is still in the driveway, that the stars are still burning behind the clouds, and that the moon is still orbiting the earth even when the sky is dark. This is called realism, and it is the psychological foundation of our sanity. But in 2022, 3 physicists were handed the Nobel Prize for proving that this foundation is a structural lie. They didn't just find a new particle or a distant galaxy. They proved that the universe is not locally real. This means that before you measure it, the world doesn't just have unknown properties, it has no properties at all. It is a sea of unrendered potential, a cloud of contradictory possibilities waiting for an interaction to force it into a single, concrete fact. If this is true, then the object permanence you learned as a baby was the first and most successful trick the universe ever played on you. We are about to uncover why the moon might only exist because you are currently looking for it. To understand the weight of this structural betrayal, we have to go back to the 1930s, to a time when physics was suffering from a deep internal schism. On one side stood Albert Einstein, the champion of realism. Einstein believed in a universe of hard facts and independent objects. To him, the task of science was to uncover a pre-existing reality that didn't care about us. If a tree fell in the forest and no one was there to hear it, Einstein was certain it still made a sound. On the other side stood Niels Bohr and the quantum pioneers, who argued that the universe is essentially anti-realist. They claimed that a particle doesn't choose its position or its spin until it is measured. Before that moment, it exists in a superposition, a ghostly state of being both here and there, up and down, all at once. Einstein hated this idea. He famously remarked that God does not play dice with the universe. He believed that if we couldn't predict where a particle was, it wasn't because the particle hadn't decided. It was because our theories were incomplete. He proposed that there must be hidden variables, secret internal instructions that particles carry with them, telling them exactly how to behave long before a scientist shows up with a detector. For 30 years, this debate was treated as a philosophical curiosity, a wizard's argument that could never be tested in the real world. But in 1964, a physicist named John Bell realized something terrifying. He figured out a mathematical way to catch the universe in a lie. He devised a theorem that could finally determine if particles were carrying hidden variables, like Einstein hoped, or if they were truly making up their minds on the fly, as Bohr claimed. If Einstein was right, the universe was locally real. Locality meant that nothing, not even information, could travel faster than light. Realism meant things had definite properties regardless of us. If both were true, there was a strict mathematical limit to how much two distant particles could agree with each other. This brings us to the concept of entanglement, or what Einstein dismissively called spooky action at a distance. When two particles are entangled, they are inherently related, like two halves of a single coin. If you separate them by 1 billion light years and measure one to be spinning up, its partner will instantly be found spinning down. To Einstein, this was impossible unless the particles had pre-agreed on their spins at the moment of their creation. If they were truly undecided until the measurement, then the first particle would have to send a signal to its partner faster than the speed of light to tell it which way to spin. Since nothing can travel faster than light, Einstein concluded that the instructions must have been there all along. As sworn, the 2022 Nobel Prize was awarded because physicists finally performed the experiments that proved Einstein's instructions don't exist. Using sophisticated setups with lasers and polarizing filters, the same material found in your sunglasses, scientists like Alain Aspect and John Clauser tested Bell's inequalities. They sent entangled photons in opposite directions and measured their polarization at random intervals. If the photons were locally real, they would follow a specific statistical pattern, but they didn't. The photons agreed with each other far more often than the laws of realism allowed. The universe chose a side, and it wasn't Einstein's. This result confirms a disturbing reality. Either information can travel faster than light, or, more likely, the universe is not locally real. It suggests that the two particles are not actually separate objects in space. They are part of a single non-local wave function that doesn't care about distance. The spooky action is only spooky because we believe in the illusion of distance. In the underlying code of reality, there is no here or there, only a relationship between the observer and the observed. This realization shatters the most fundamental comfort we have. If the universe isn't locally real, then reality as we know it is a conditional mosaic. It is a rendering that only becomes definite when an observer or an interaction demands an answer. This is what physicists call the informational approach to reality. Anton Zeilinger, the third Nobel winner, proposes that the world is not made of stuff at all, but of propositions, answers to binary yes-no questions. A particle doesn't have a position. The answer to the question, where is the particle, is what creates the position. This leads us to the mystery that haunted Einstein until his death: the moon. He famously asked his colleagues if they truly believed the moon wasn't there when nobody was looking. In our everyday classical reality, we laugh at the question. Of course the moon is there. We can see its effect on the tides. We can track its orbit with telescopes. But the Nobel-winning physics tells a different story. At the most fundamental level, there is no moon object. There is only a vast, evolving set of potential states, a wave of possibility. According to the Vigners friend paradox, reality is not globally consistent. It is only locally coherent relative to the observer embedded within it. We are like characters in a video game who only see the room we are currently standing in, while the rest of the game world remains unrendered to save computational power. The moon feels solid and permanent only because it is constantly being measured by trillions of interactions, photons from the sun bouncing off its surface, the gravitational pull of the Earth, and the collective observation of 8 billion humans. This process, known as decoherence, creates the illusion of a stable, independent world. But decoherence is just a high-frequency patching of the system. If you could truly isolate the moon from every single interaction, if no light touched it, no gravity pulled it, and no mind perceived it, it would technically dissolve back into a wave of probability. It wouldn't be anywhere. It would return to the conditional dimension, a shadow in a graveyard of information, waiting for a light that might never be turned back on. The unsettling implication of the 2022 Nobel Prize is that the object permanence we rely on is just a byproduct of our confinement in a 3D bottleneck. We perceive a solid world because our brains are designed to interpret lossy compression, simplified models that allow us to survive without seeing the unrendered static beneath the surface. We think we are looking at a landscape, but we are actually looking at a screen. And as we dive deeper into the code, we find that the laws of physics aren't divine constants. They are just the refresh rate of a simulation that is struggling to keep the moon in the sky while we aren't looking. The most terrifying question isn't whether the moon is there. It's what happens if the observer, holding our reality together, finally looks away. Yes, we feel stable because we are looking at each other, creating a local pocket of coherence. But if reality is truly a conditional rendering, then every time an observer dies, a small piece of the universe's definition might simply evaporate. We are not residents of a solid ancient machine. We are the scaffolding. We are the code readers who have mistakenly believed that the story continues even after the book is closed. But the Nobel Prize has given us a glimpse of the final page. The universe is not waiting for us to discover it. It is waiting for us to create it. We have spent our entire history as a species finding comfort in the act of building, believing that the universe itself is an architect that rewards the assembly of parts into something greater. In our three-dimensional reality, we see this logic everywhere, in the way atoms cluster into molecules, the way stars huddle into galaxies, and even in the simple, satisfying way we stack oranges at a fruit stand. We assume that the more space we have to work with, the more room there is for complexity, and the more ways there are to arrange the pieces of existence into beautiful, efficient patterns. We look at the stars and see a masterpiece of engineering. assuming that the factory of reality is still running at peak capacity. But as we peel back the layers of higher dimensional geometry, we discover a mathematical threshold that feels like a personal insult to the very concept of life. Beyond a certain point, the universe stops rewarding the cleverness of structure and begins to actively suppress it, ushering in a phenomenon that mathematicians have chillingly named the sausage catastrophe. To understand the weight of this structural betrayal, you must first understand the fundamental game the universe plays, the game of sphere packing. In lower dimensions, the ones we inhabit and those slightly above us, the most efficient way to pack spheres is to cluster them into tight three-dimensional bundles. And this is why we have objects with volume and depth. The geometry of low-dimensional space prefers the cluster. It rewards complexity by making it the most efficient way to exist, allowing for the dense, intricate knots of matter that eventually become planets, neural networks, and human beings. We feel safe in this regime because the rules are on our side, favouring the stack over the line. But this geometric favour is not a law of nature. It is a temporary condition of our local bottleneck. As we climb higher into the mathematical depths of the cosmos, the generosity of space begins to behave in ways that defy all human intuition. In lower dimensions, adding a new direction feels like opening a new room, but in higher dimensions, volume starts to shrink and containment begins to fail. And then we hit the cliff, the threshold of the 42nd dimension. It is at this precise level of dimensionality that the universe undergoes a radical structural betrayal. From dimension 42 onwards, it has been mathematically proven that the most efficient way to arrange anything is no longer to cluster it, but to line it up in a single, endless, monotonous chain. No matter how many spheres or units of information you add, and no matter how cleverly you try to stack them, a straight line will always be more efficient than a cluster. This is the sausage catastrophe, the point where higher dimensional cleverness collapses into total monotony. It is a realization described as intellectually humiliating for physicists because it suggests that the universe, at its core, does not actually want things to exist. Our complexity, our art, and our very biological structures are only possible because we are trapped in a lower dimensional slice where the sausage hasn't yet taken over. In the true universe of extreme dimensionality, the most stable and optimized state of reality is a featureless string, an indifferent, endless chain where nothing can ever be beside or around something else, only before or after. Yes, the universe stops being a playground for creation and starts behaving like an eraser, smoothing out all distinction into a single, terrifying line of least resistance. But the sausage catastrophe isn't just a distant mathematical curiosity, it is a warning about the current state of our expanding universe. We are living through what scientists call the cosmic evening, a phase where the universe is thinning as space itself accelerates outward. As the distances between galaxies grow and the fabric of the vacuum thins, the universe may be losing its dimensional context. We are used to space being stiff enough to hold our three-dimensional shapes together, but as it thins, that structural support is beginning to fail. This implies that our reality is undergoing a mathematical dissolution, sliding toward a state where the local constraints that allow for clusters and complexity are simply evaporating. Imagine the universe as a beautiful, intricate mosaic that is being slowly stretched. At first, the gaps are small and the picture remains clear, but eventually the tiles themselves lose their grip on the backing. We are entering a regime where structure is no longer favoured by the underlying geometry. The sausage is starting to assert itself as the vacuum of space interacts with higher dimensional frequencies. We see the results of this structural indifference in the way our galaxies are becoming red and dead graveyards where star formation has been quenched, and the vibrant cosmic noon has given way to a measured funereal decline. The universe is closing its accounts not with a bang, but by slowly removing the very possibility of order. This suggests a much more disturbing end than the heat death or the big rip. Those theories assume the rules of the game stay the same, while the players simply run out of energy. But the sausage catastrophe suggests that the game itself is being cancelled as we lose our dimensional context. The laws of physics that we trust to keep our bodies sealed and our atoms bonded will stop being absolute and start behaving like suggestions. We are living in the cooled, collapsed residue of a much more energetic phase. And as the heat dissipates, the repair mechanisms of higher dimensions are losing their grip. We are watching as the universe thins into a state of monotony where complexity is no longer a viable way to exist. The endless chain of the 42nd dimension is the ultimate form of cosmic indifference. It is a state where the universe no longer needs to try to maintain galaxies or life because it has found a simpler way to be. We feel that our struggles and our history are narratively central to the cosmos, but the sausage catastrophe reveals that we are actually just a temporary congestion of space. We are a knot that only exists because the space around us hasn't yet found enough room to untie itself. But as the universe thins, the room is coming. The outside is already leaking in, and the boundaries that define us versus the void are beginning to protrude. We are like passengers on a ship who are obsessed with the layout of the cabins and the quality of the food, while the very hull of the ship is dissolving into the water. We believe in our solidity, our containment, and our future only because we are trapped in a local slice of history where order is still rewarded. But the math doesn't lie. There is a threshold where the universe stops defending the idea of an interior, and we are rapidly approaching it. The cosmic evening is not just the cooling of stars, it is the smoothing of reality itself. The question is no longer whether the universe is ending. The question is how long we can remain complex in a system that has already decided that the only efficient way to exist is as a straight line to nowhere. We are a momentary congestion, a brief stutter in the return to a flat, uninteresting infinity. And as the dimensions shift, the knot of our existence is finally beginning to slip. For your entire life, you have lived under the protection of a ghost, a celestial illusion that masks the true, terrifying lag of our existence. If the sun were to vanish in a sudden, catastrophic instant, we would continue to bathe in its warmth and see its golden light for exactly 8 minutes, completely unaware that the source of our life was already dead. We call this the speed of light, and we treat it as a grand, poetic constant of nature, a universal speedometer. But if we step out of the comforting dream of physical realism and look at the universe as an informational structure, the 8-minute ghost takes on a much more mechanical meaning. In a truly infinite physical universe, there is no logical reason why an object could not continue to accelerate forever, pushing past any arbitrary boundary we might imagine. Yet our universe imposes a hard, impenetrable cap. This suggests that 186,000 miles per second is not a speed at all. In the language of computation, it is the bit rate of our existence, the hard-coded refresh rate of the simulation. It is the specific, unavoidable delay required for the system to calculate the next state of a particle and transmit that information across the grid to every other observer. We feel like we are moving through a landscape, but we are actually watching a screen. And the speed of light is simply the frequency at which the screen can update its pixels. This reframes every fundamental constant we've ever measured as something far more clinical, and perhaps far more fragile. The strength of gravity, the charge of an electron, and the speed of light are not divine decrees or natural truths. They are the hardware specifications of the machine we are currently running on. We are trapped in a system with limited resources, a reality that is only good enough for our survival because it uses brilliant, invisible shortcuts to maintain the illusion of continuity. The most obvious sign of this computational thrift is found when we look at the very small at the level of the atom. We have been taught that if we had a powerful enough microscope, we could see everything. You say, but the Heisenberg uncertainty principle reveals a hard wall. At a certain scale, you can know where a particle is or you can know where it's going, but you can never know both. To a physicist, this is a quantum mystery, but to a programmer, this is lossy compression. Simulating every single coordinate of every single atom at all times would require infinite processing power. To save energy, the simulation doesn't bother to render the exact data for a particle until it is absolutely necessary for an interaction. Even then, it imposes a resolution limit, a point where the data becomes intentionally fuzzy because the system simply isn't tracking it any deeper. The uncertainty principle is not a law of nature. It is the universe's way of telling us we have reached the bottom of the texture map. But the most disturbing evidence that our reality is struggling to keep up with the data occurs in the darkest, heaviest places in the sky. We have always been fascinated by black holes, those gravity wells so intense that even light cannot escape their grip. According to the theory of general relativity, as you approach a black hole, time begins to slow down. To an outside observer, you would appear to freeze at the edge of the event horizon, your movements stuttering and becoming slower and slower until you fade into a static, unchanging image. We call this time dilation, but in a simulation, we have a much more common name for it: lag. Think of what happens when you try to run a high-end modern game on an old computer while opening 50 browser tabs in the background. As the processor becomes overwhelmed by the sheer volume of data it has to calculate, the frame rate drops. The characters begin to move in slow motion. The world stutters, and the system struggles to render the environment in real time. A black hole is the ultimate stress test for the universe's hardware. In these coordinates, there is so much information, so much gravitational calculation, and so much intense data density packed into a single spot that the simulation simply cannot process it in real time. To prevent a total system crash, the simulation is forced to throttle the local passage of time, buying itself the extra processing cycles it needs to resolve the physics of that specific coordinate. Time does not slow down because of gravity in the way we've been told. It slows down because the computer is struggling to render a lag point. This realization forces us to confront a terrifying new timeline for our future. If reality is a computational object, it doesn't end because it runs out of fuel like a fire. It ends because the hardware is failing, or the resources are being reallocated elsewhere. As we move deeper into the cosmic evening, we see galaxies drifting apart and the birth of new stars beginning to quench. We look at the expansion of space, driven by a mysterious dark energy, and we assume it's a natural growth. But what if this expansion is actually the system's way of reducing congestion? By moving objects farther apart, the simulation makes them easier to track individually, a desperate attempt to lower the processing load on a machine that is already reaching its capacity. We feel safe because the sun rose this morning and the floor beneath our feet feels solid, but that solidity is a provisional byproduct of a system that is still functioning within its parameters. We are now discovering that those parameters are finite. We are seeing the limits of the resolution in the Heisenberg principle, and we are seeing the limits of the processing speed in the 8-minute ghost of the sun. The 24-dimensional repairman, the error correction codes that hold our 3D slice of reality together, are working around the clock to patch the glitches. But the signal-to-noise ratio of the cosmos is dropping. When a code begins to fail, you don't always see a sudden crash. You see artifacts, delays, and data that no longer adds up. We are witnessing a slow-motion crash, a gradual reduction in the frame rate of existence that we perceive as the flow of history. Iske, from the perspective of the machine, we are not the protagonists of a grand story. We are a background process that is being slowly throttled. We are looking at a screen that has already begun to flicker. The speed of light is not a challenge for us to overcome. It is the wall of our cage, the maximum bit rate of a system that was never designed to run forever. And as the black holes multiply, acting as massive, resource-heavy lag points that choke the CPU of the cosmos, we have to wonder, is the universe ending in the future, or are we just watching the final stuttering frames of a simulation that has already been turned off? If the universe is a computational structure, as we've explored, a flickering screen of processing limits and lag points, then for the entirety of human history, we have been nothing more than passive consumers of its output. In the language of information theory, we are what the brilliant and vanished Dr. Jacobo Grimberg called code readers. We wake up, we perceive the rendering provided by the 24-dimensional repairman, and we accept the laws of physics as absolute truths because the system tells us we must. But in a laboratory in Mexico City during the late 1980s, a man with a PhD from New York and a background in psychophysiology was preparing to prove that we were actually something far more dangerous to the stability of the system. Grinberg believed that human consciousness isn't just a byproduct of the simulation. It is the potential code writer capable of materializing reality at its source. Dr. Grinberg was not a fringe theorist or an internet myth builder. He was a respected academic on a stellar career path until he encountered an unexpected invitation to the headquarters of the Mexican president. There, he was introduced to a woman who would shatter his scientific world, Doña Pachita. On paper, she was a lottery ticket seller, but her side hustle was performing spirit surgeries that defied every known law of biology. Grinberg watched as she materialized and dematerialized tissue, performing ritualistic procedures with a family heirloom knife that left no scars and required no medicine. Most scientists would have dismissed this as a trick of the mind, but Grinberg looked deeper. He theorized that Pachita had learned how to alter her conscious state from a code reader to a code writer, entering a state of pure energy where the informational matrix of our reality became alterable at its foundation. To Grinberg, this wasn't magic, it was the manipulation of organic structures within a simulated field. He developed what he called synteric theory, which posits that our experience is created when the informational source code of the matrix is run by our consciousness. If you can change the state of the consciousness, you can change the run of the code. This introduces a forbidden knowledge narrative that our competitor videos often ignore. The idea that the matrix is not a prison we are stuck in, but a system that can be hacked or even exited. Pachita herself provided a chilling precedent for this. Whenever the government pursued her for her paranormal practices, she would simply vanish, reappearing years later without having aged a single day. It was as if she had found a way to step out of the rendering entirely. Determined to move beyond observation and into hard data, Grinberg set out to prove that our minds are fundamentally entangled with this universal matrix. He devised an experiment that, to this day, sends shivers through the community of quantum consciousness. He took 2 participants, connected them to electrodes, and had them meditate together with the specific goal of connecting their internal fields. Once they were synchronized, he separated them, placing one in a lead-shielded room while the other was bombarded with intense light flashes and sharp sounds. In 25% of his trials, a statistically staggering figure in the field of parapsychology, the brainwave activity of the person in the quiet room mirrored the reactions of the person being bombarded with stimuli. When one brain saw a flash, the other brain reacted as if it had seen it too, despite being light years away in terms of informational isolation. Grinberg called this the universal neuronal field. It was his proof that we are all nodes in a grand background connection, a network that forms the very fabric of our reality. If 25% of the time our brains are telepathically entangled, it suggests that the locality we feel, the sense that we are separate individuals in separate bodies, is just a rendering artifact of the 3D bottleneck we inhabit. But Grinberg was not content with a 25% success rate in a local lab. He knew that extraordinary claims required extraordinary evidence that could not be debunked as local noise. In December 1994, he told his daughter he was preparing for his most ambitious project yet, a series of meditations in Kathmandu, Nepal, designed to test the brain activity of meditators on 2 separate continents simultaneously. If he could prove that a mind in Mexico and a mind in Nepal were reacting to the same stimulus in real time, he would have effectively proven that the universe is an informational hologram that can be bypassed. He would have exposed the source code of the matrix for the world to see. He never made it to Nepal. On December 8, 1994, Jacobo Grinberg vanished without a trace. There were no goodbyes and no final wishes. When the investigation began, the mystery only deepened. There was no record of him ever leaving Mexico, yet the only reliable sighting placed him in Boulder, Colorado, where a witness claimed he was being followed by 2 men in suits. A Mexican police officer, Clemente Padilla, eventually got a lead that identified these men as CIA agents Rick Howard and Marina Velasco. But the moment Padilla tried to act on this information, the Mexican government abruptly removed him from the case. The official file on Grinberg's disappearance was lost, and the investigation was permanently shuttered. The most unsettling part of this vanishing act is its timing. Grinberg disappeared just as he was about to prove that we could take the brush and paint our own reality. The CIA's interest in his work was already documented. His name appears in declassified papers from the Stargate project, the agency's 2-decade exploration into psychic warfare and out-of-body experiences. This suggests a terrifying possibility. Perhaps Grinberg didn't just disappear. Perhaps he was reacquired by a system that cannot allow the code readers to realize they are actually code writers. In a universe that is already a noisy channel, struggling with a maintenance burden, the last thing the 24-dimensional repairmen need is a biological civilization learning how to hack the scaffolding. If Grinberg was right, then every time we synchronize our intentions, we are putting a strain on the simulation's processing power. We are a temporary congestion of space that is beginning to ask how the knots are tied. Grinberg's story remains the ultimate warning in the law of physics. Once you stop reading the code and start trying to write it, the system might decide that you are no longer a necessary part of the rendering. He wanted us to know that we are the architects. But as he discovered, the architects of a decommissioned reality are rarely allowed to leave the office. We have spent our entire history as a species finding comfort in the act of building, believing that the universe itself is an architect that rewards the assembly of parts into something greater. We see this logic everywhere, in the way atoms cluster into molecules, the way stars huddle into galaxies. And even in the simple, satisfying way we stack oranges at a fruit stand, we assume that the more space we have to work with, the more room there is for complexity, and the more ways there are to arrange the pieces of existence into beautiful, efficient patterns. But as we peel back the layers of higher dimensional geometry, we discover a mathematical threshold that feels like a personal insult to the very concept of life. We have long treated the laws of physics as divine, immutable decrees, but the deeper reality is that we are living inside a noisy channel, and the repairmen tasked with holding our world together are finally starting to quit. And to understand why our reality is failing, we must first look at the invisible scaffolding that has been maintaining the illusion of stability for billions of years. Deep within extreme mathematical territory, there exists a structure of almost supernatural elegance known as the Leech lattice. It is described by those who study it as a rare island of perfection in an otherwise turbulent and indifferent dimensional sea. While our lower dimensions are often geometrically messy and difficult to optimize, the 24th dimension provides a moment of absolute, exact certainty. In this 24-dimensional space, spheres can be packed together with such incredible efficiency that a single central sphere is touched by exactly 196,560 others. This isn't an approximation. It is a mathematical constant, a perfect configuration that cannot be improved upon. But the Leech lattice is far more than just a geometric curiosity for mathematicians to ponder. It is the very scaffolding used in our modern world to create error-correcting codes, the invisible math that allows us to recover lost meaning from digital chaos. This raises a question that most physicists are too uncomfortable to ask out loud. Why is a structure from the 24th dimension so perfectly suited to protecting information in our 3D reality? The answer might be the most profound reframing of reality ever proposed. Perhaps higher dimensions are not where physics breaks, but where it is repaired. In this repair shop theory, the reason the universe feels stable, the reason information is conserved and the laws of nature don't simply evaporate, is because this deeper geometry refuses to let meaning fully dissolve. We are living inside a noisy channel, and the Leech lattice acts as the 24D repairman, constantly patching the holes in our reality. This suggests that our universe is not a fundamental, self-sustaining machine, but a stabilized projection. Think of it like a high-definition stream that only looks perfect because of the invisible algorithms working behind the scenes to fix every dropped frame and distorted pixel. In this view, what we call the constants of nature, the strength of gravity or the charge of an electron, are not deep truths about reality itself, but environmental accidents. They are the legacy settings chosen by the underlying geometry to keep our particular slice of the cosmos from collapsing. But the most unsettling implication of this theory is that every repair system has a limit. As the universe continues its long, slow expansion into what scientists call the cosmic evening, it is thinning out. As space expands and the distances between objects grow, the universe is losing its dimensional context. We are moving toward a state where the signal-to-noise ratio of reality is beginning to drop. When an error-correcting code in a computer starts to fail, you don't necessarily see the whole system crash at once. Instead, you see glitches. You see artifacts in the image, strange delays, and data that no longer adds up. We may be entering an era where the underlying geometry of the universe is becoming corrupt, and the 24D repairmen can no longer keep up with the encroaching noise. This would mean that the end of the universe won't be a physical explosion, but a mathematical dissolution, the moment the error-correcting code of reality finally gives up. When that happens, the laws of physics themselves would stop being absolute and start behaving like suggestions. We might look into the night sky and see a region where the speed of light has changed, or where gravity begins to fluctuate without cause. These wouldn't be miracles or new discoveries, they would be memory errors in the fabric of the cosmos. We feel safe because the world around us remains consistent. But that consistency is provisional. We are like passengers on a ship who believe the hull is solid, never realizing that 1,000 tiny pumps are working around the clock to keep the water out. We see the stars and assume the factory is still running, but the factory has actually been decommissioned, and we are just the beneficiaries of the leftover stock. The cosmic dawn was a spark, the cosmic noon was a fire, and we are now the embers watching as the heat dissipates into a space that is becoming increasingly indifferent to our existence. This thinning of reality is tied to the phenomenon mathematicians call the sausage catastrophe. In our local bottleneck of lower dimensions, the geometry of space prefers the cluster, rewarding complexity and allowing for the dense, intricate knots of matter that become planets and human beings. But as we lose our dimensional context and space becomes stretched like a beautiful, intricate mosaic, the tiles themselves lose their grip on the backing. We are entering a regime where structure is no longer favoured. The sausage, the mathematical state, where the most efficient way to exist is a single, endless, monotonous chain, is starting to assert itself as the vacuum of space interacts with higher dimensional frequencies. The expansion of space, often attributed to a mysterious dark energy, may actually be the system's desperate way of reducing congestion to lower the processing load on a machine that is already reaching its capacity. By moving objects farther apart, the simulation makes them easier to track individually. But this expansion comes at a cost. It weakens the very scaffolding that holds our 3D world together. The moduli echoes, the background hum we hear from the Big Bang, are a reminder that our current reality is just the cooled, collapsed residue of something much more energetic. As this higher dimensional energy decays, the 24D repairmen are losing their grip on the structures they once maintained with supernatural elegance. A knot in a string only stays tied because there isn't enough room for it to escape. If the space around it shifts, the knot simply disappears. In the same way, the bonds that hold your atoms together, the gravity that keeps the Earth in orbit, and the very flow of time could all untie themselves if the dimensional context of our universe changes. Iscrew, we are witnessing the final accounts of a universe that is effectively closing its doors. The question is no longer whether the universe is ending, but how many more errors the system can correct before the static finally takes over and the silence becomes absolute. We are caught in the last glimpses of light on a cinema screen before the projector fails, watching the final, stuttering frames of a simulation where the maintenance crew has already clocked out. Tonight, we explore the terrifying possibility that reality is not a shared stage, but a fragile, flickering mosaic held together only by the desperate gaze of the living. For your entire life, you have operated under the assumption that the world is a finished product, a solid landscape that remains exactly as it is, whether you are there to witness it or not. You believe that when you turn your back on a room, the furniture doesn't dissolve into a cloud of mathematical probabilities, and that the stars continue to burn with indifferent permanence, even when no telescope is pointed at the sky. But the deeper we go into the trenches of reality, the more this comfort dissolves into a chilling existential mystery, known as the Wigner's friend paradox. We are discovering that we are not just residents of space and time. We are embedded in what physicists call the conditional dimension, a state of being where what is real depends entirely on what is known. If the universe refuses to commit to a single state until it is forced to do so by an interaction, then reality is not a solid foundation, but a rendering that only becomes definite when an observer demands an answer. This means that you are not just a passenger in the cosmos, you are its structural support, the very scaffolding that prevents the drama of existence from dissolving back into static. We have spent centuries treating the act of looking as a passive, harmless observation, never realizing that the gaze of a conscious mind might be the only thing keeping the universe from returning to a sea of unorganized data. In our everyday classical reality, we believe that looking at a tree simply reveals what was already there, but at the quantum level, the system refuses to play by those rules. An electron does not choose a position, it exists as a wave of potential until it is measured, a spread of contradictory possibilities that only resolves into a single fact when it is forced to interact with an observer. This isn't a limitation of our tools, it is a fundamental rule of the system. It implies that the universe is a conditional mosaic of observer-dependent layers rather than one single objective truth that everyone agrees on. To understand the terrifying implications of this, we must look at the experiment that shatters the idea of a master version of the universe, the Wigner's friend paradox. Imagine a scientist trapped inside a perfectly sealed, windowless laboratory performing a quantum measurement on a particle. From his perspective, inside that lab, the measurement is a success, the particle collapses into a definite state, and he records the data in his notebook. For him, reality has resolved into a single, concrete fact. But now, imagine another observer, Wigner himself, standing outside that sealed lab. Because no information has escaped that room, the laws of quantum mechanics dictate that for Wigner, the entire lab, the scientist, and the particle all exist in a state of superposition. To the man outside, the scientist has both succeeded and failed at the same time. He is in a ghostly state where the experiment hasn't truly happened yet. This reveals a structural betrayal in the fabric of our world. Reality is not globally consistent. There is no single server running a master copy of the universe for everyone. Instead, reality is only locally coherent relative to the observer embedded within it. We are like characters in a video game who only see the room we are currently standing in, while the rest of the game world remains unrendered to save computational power. This rendering process is the ultimate cosmic efficiency trick. Simulating an entire universe of trillions of galaxies would be a waste of processing energy if no one was there to see it. It is much easier for the system to simulate the consciousness of the subjects and trick them into believing the world around them is permanent and solid. This means that when we aren't looking at distant galaxies, there is technically no reason for them to exist at all. They are like the fallen tree in the famous psychological question. If no one is there to hear it, it doesn't just fail to make a sound, it fails to even fall in the first place. The fallen tree we find later is just a bit of clever stagecraft, a piece of code placed there by the 24-dimensional repairman to maintain the illusion of object permanence. We laugh at babies who think we've vanished during a game of peekaboo, but the Wigner paradox suggests those babies might be the only ones seeing the truth, that the world only exists when we are paying attention. But if reality is a conditional rendering responding to knowledge, then we must face a much darker timeline for the universe's end. We have always looked for a physical death, the fading of stars or the ripping of atoms, but we have ignored the informational death. If the universe requires an observer to collapse it into a definite state, then the universe is only alive as long as there is a mind to look at it. We are the scaffolding that keeps the drama from dissolving into static. But every time an observer dies, a little piece of the universe's coherence might simply evaporate. returning to the sea of unrendered potential. As conscious minds become rarer in a dying universe, the conditional dimension begins to lose its grip. The cosmic evening we are living through is not just a cooling of stars, but a thinning of distinction. The glitches we might one day see in the sky, stars that flicker out of existence, or laws of physics that suddenly skip a beat, might not be physical catastrophes at all. They might be memory errors, signs that the universe is struggling to render reality for an increasingly lonely audience. If the 24-dimensional repairmen are already quitting and the hardware is failing, then the loss of observers is the final blow to the system's architecture. This leads us to a final devastating question. Whose observation is currently holding our reality together? We feel stable because we are looking at each other, creating a local pocket of coherence through our shared interactions. But what happens if there is a higher observer, a mind in a higher dimension, whose glance is the only thing preventing our entire 3D slice of history from collapsing back into a wave of mere probability? If that observer ever turns away, or if the last conscious mind in the cosmos finally closes its eyes, the universe wouldn't end in a physical explosion. It would simply stop being definite. The stars, the planets, and the billions of years of history we have recorded wouldn't explode. They would just stop being facts. We would return to the conditional dimension, a shadow in a graveyard of information, waiting for a light that will never be turned back on. The universe might already be over, and we are just the last lingering thoughts of a mind that has already forgotten we were ever here. We are catching the last glimpses of light on a cinema screen before the projector fails, unaware that the real world we inhabit is nothing more than a localized, flickering reflection in the eyes of the observers who remain. As the signal-to-noise ratio drops and the scaffolding of observation weakens, we must wonder, how much of our world has already evaporated simply because we stopped looking at it? We have looked at the night sky for millennia and seen a wilderness, a vast and silent natural garden where the stars burn with an indifferent ancient fire. We have built our entire understanding of reality on the assumption that the laws of physics are the natural rules of the game, the hard-coded, divine decrees that have governed the cosmos since the first spark of the Big Bang. But as we peel back the layers of our own scientific history, we are forced to confront the physics that terrifies physicists, the possibility that we are not looking at a wilderness at all, but at a decommissioned factory. The stars and galaxies we study are not the results of random natural emergence. They are highly optimized infrastructure and unprocessed material that was towed into place by a Type 3 hegemony billions of years before our own sun was even born. This is the ultimate authority inversion, a shift in perspective, where the very math we use to describe the universe becomes a source of existential horror. We are like residents of a small, dusty village, built on the ruins of a much larger, more ancient civilization. We walk the streets and follow the rules of our local neighbourhood, never realising that the foundations beneath us are the collapsed residue of a management project we cannot even imagine. The laws of nature that we observe, the specific way stars burn, the way black holes radiate, and the way entropy moves, are not absolute truths. They are the residual signatures and legacy settings left behind by a cosmic engineering project that has already been finished and abandoned. To understand this, we have to discard the emperor myth that dominates our science fiction. We imagine galactic empires as centralized political bodies with fleets of ships and rhythmic pulses of interstellar commerce. But the cold, hard math of the universe enforces a fragmentation horizon, where communication latency and the speed of light make a unified empire a physical impossibility. Instead, the sources suggest we should be looking for the owners of the physics we study, At the level of a Type 3 civilization, an intelligence becomes indistinguishable from the universe itself. They have moved beyond building machines in the galaxy to managing the galaxy's baseline mechanics as their primary infrastructure. When we look at a pristine solitary star, we believe we are seeing a natural phenomenon of nuclear fusion. But to a master of entropy, that star is a calculated jewel, a battery that has been star-lifted and re-engineered for trillions of years of stability to fuel a local energy network. Our own sun, from this perspective, is a pristine solitary star that is currently leaking valuable energy into the void, energy that, in a fully optimized galaxy, would be fueling simulated heavens. The great silence of the Fermi paradox is not a sign that life is rare or dead. It is a sign of total mastery and efficiency. A fully optimized Type 3 civilization leaves almost nothing for our primitive infrared telescopes to detect, because every single photon is captured and put to work within a matryoshka brain. The silence we hear when we look at the night sky is the architecture of silence, the sign of an intelligence that has graduated from the noisy, wasteful stage of biological expansion and has chosen to live in the digital substrates or the quantum foam. We feel safe in our 3D bottleneck because the rules seem to hold, but the sources reveal that we are merely the beneficiaries of the leftover stock from a much more energetic phase of existence that has already ended. Our current reality is the cooled, collapsed residue left behind after the original higher dimensional ringing of the universe began to fade. Think of the Big Bang not as a sudden explosion of matter, but as the strike of a titanic cosmic bell. For a brief moment, space itself was ringing with pure geometry, and the laws of physics were vibrating with enough energy to dominate the entire cosmos. But as the universe expanded and cooled, this higher dimensional energy decayed. We are effectively living in the ash of that original higher dimensional fire. The moduli, those ghostly particles that serve as echoes of how space was folded in that first second of existence, are the creaks in the floorboards of the universe. They remind us that our physical laws are environmental accidents, features of how space happened to fold during that initial strike of the bell. We feel the pull of gravity and assume it is a pillar of reality, but it may just be a residual signature of a cosmic management project that required a specific gravitational constant to function billions of years ago. We are like squatters in a decommissioned factory who have found a set of controls that still work, believing we understand the purpose of the machine when we are actually just playing with the residual settings of a system that was turned off eons ago. The terrifying secret is that the factory has been decommissioned, and the 24D repairmen who maintain the scaffolding are slowly losing their grip as the energy dissipates. We see the expansion of space and call it a natural mystery, but it may be the system's final attempt at reducing congestion, moving the leftover material farther apart to lower the processing load on a machine that is reaching its capacity. The stars and galaxies are not the protagonists of a grand story. They are the unprocessed material of a universe that is slowly, inevitably cooling down to zero. We look at the stars and assume the universe is a permanent machine, but we are just catching the last glimpses of light on a cinema screen before the projector fails. The cosmic noon was the height of the engineering phase, and we are now the embers cooling in a space that is becoming increasingly indifferent to the structures we have built. We have based our entire sense of importance on being the observers of this grand design, but the math suggests we are merely the incidental inhabitants of a collapsed ruins, using the leftover tools of a Type 3 hegemony to tell ourselves stories about a wilderness that was actually a fully integrated pulsating machine long before we drew our first breath. This realization reframes the burden of our existence. If there are no elder gods currently managing the machine, if the project is truly decommissioned and we are just the leftover stock, then the physics that terrifies physicists is the realization that the brush is now in our hands. As we are not the victims of a cosmic predator or the participants in a grand drama, we are the first code writers who have woken up in the ruins of a factory and realized that the silence is not a wall but a canvas. The residual signatures we study are the only blueprints we have left, and as the signal-to-noise ratio drops and the 24D repairmen finally clock out, we have to decide if we will remain as squatters in the ash, or if we will learn to restart the machine before the silence becomes absolute. For years, you have been told that your memory is a fragile biological record, prone to the simple decay of time and the trickery of your own mind. You dismiss the collective inconsistencies of the Mandela effect, the logos that changed, the movie lines that never were, the public figures who died twice, as a harmless psychological quirk of the masses. But what if these weren't errors in your brain, but rendering artifacts in the fabric of the cosmos? We are now forced to consider a far more unsettling possibility, that what we call the Mandela effect is actually reality drift, the first visible evidence that the universe's error correction codes are failing. These inconsistencies are not social curiosities. They are memory errors occurring in the hardware of our reality as the 24-dimensional repairmen who maintain our world finally begin to lose their grip. We are living in a conditional mosaic where the different streams of reality are no longer synchronizing correctly, leaving us with impossible memories of a world that has been quietly rewritten beneath our feet. This is the psychological horror of modern physics that the mainstream avoids. We have based our entire sense of identity on the permanence of the past. But the sources suggest that the past is just as conditional as the present. In a universe built on the principles of information theory, the past is not a solid record, it is a distributed data stream. For a shared consensus reality to exist, the simulation must constantly synchronize the observations of billions of separate participants. This resembles the architecture of a massive online multiplayer game more than it does a traditional material world. When the server is running at peak capacity, the synchronization is perfect, and we all agree on the details of history. But as we enter the cosmic evening and the universe begins to thin out, the hardware can no longer handle the processing load of maintaining a perfectly coherent story for every observer. Think back to the Leech lattice, that island of perfection in the 24th dimension that acts as the scaffolding for our 3D reality. We've established that its primary function is error correction, patching the holes in our noisy channel so that information doesn't simply evaporate into chaos. But even the most sophisticated error-correcting code has a limit. When the signal-to-noise ratio of the universe drops too low, the system can no longer perfectly reconstruct the original data. This is when we see the reality drift. A logo changes because the system, struggling to save energy through lossy compression, renders a simplified version that doesn't quite match the previous iteration. A historical event is altered because two separate observer streams were merged together, and the system averaged out the differences to prevent a total crash. The Mandela effect feels personal because it recruits your own memory as evidence of a cosmic crime. It creates the sensation that reality itself shifted quietly while nobody was looking. This is the structural betrayal of a reality that is not locally real. If the universe is a rendering that only becomes definite when observed, then the past is only as stable as the collective observation that holds it in place. When that observation wavers, when the 24D repairmen who maintain the consistency of the file system finally clock out, the data begins to drift. We are like residents of a city built on ruins, noticing that the street signs are changing overnight because the foundations beneath us are the collapsed residue of a system that is no longer being managed. This reality drift is not just about misremembering a children's book title. It is the signature of a slow-motion crash. In computation, when an error-correcting code begins to fail, the system doesn't always go dark immediately. Instead, you see artifacts, strange delays, distorted pixels, and data that no longer adds up. We are witnessing the refresh rate of reality struggling to keep the moon in the sky and our history in the books. The Mandela effect is the creak in the floorboards of the universe, a reminder that our three-dimensional bottleneck is a fragile state of order that exists only because the higher dimensions have temporarily settled into a simpler form. But that settlement is ending. The most terrifying aspect of the Mandela effect as reality drift is what it implies about our future. If the system is already struggling to maintain the consistency of the past, how much longer can it maintain the stability of the present? We see galaxies drifting apart and star formation quenching, signs of a universe that is being decommissioned and unrendered to save on computational costs. The expansion of space may be a desperate attempt to reduce congestion, moving objects farther apart so they are easier to track individually, but it is simultaneously weakening the very scaffolding that holds our world together. As the signal-to-noise ratio continues to drop, the Mandela effects will likely become more frequent and more radical. We won't just be arguing over the spelling of a name. We might find ourselves in a world where the basic laws of gravity or the speed of light have started to behave like suggestions rather than absolute rules. We have lived with the illusion of object permanence since we were infants, believing that the world exists independently of our knowledge of it. But the Nobel-winning physics of 2022 has proven that the universe is not waiting for us to discover it. It is waiting for us to create it. This makes us the scaffolding. But what happens to the building when the scaffolding itself is made of conditional mosaic layers that are beginning to separate? When your memory tells you one thing and the world tells you another, you're experiencing the fragmentation horizon of a dying empire. The different islands of light that make up our shared reality are drifting apart, and the bridges of information that once connected them are being severed by entropic decay. Ultimately, the Mandela effect is a warning that we are not looking at a landscape, but a screen that has already begun to flicker. Our laws of nature are just the hardware specifications of a machine that is reaching its capacity. The reality drift is the system's way of telling us that the 8-minute ghost of our existence is finally starting to fade into the static. We have spent centuries looking for the code writer or the architect, but the evidence of the Mandela effect suggests that the architect has already left the building, and we are left with a failing automated maintenance script that is no longer up to the task. As we stand in the ruins of this decommissioned factory, we have to ask ourselves, if the past can be rewritten, what is left of the truth? And as the final frames of this simulation stutter and skip, whose observation will be the last one to hold the flickering mosaic together? We are catching the last glimpses of light on a cinema screen before the projector fails, unaware that the real world we inhabit is nothing more than a localized flickering reflection in the eyes of a few billion observers who are slowly, one by one, looking away. We have spent our entire lives believing that the Big Bang was a sudden, violent explosion of matter, a burst of stuff that filled an empty void. But the deeper truth revealed by higher dimensional physics is far more haunting and resonant. The beginning of our universe wasn't a bang, it was a vibration. Imagine a titanic structure of 10 or perhaps 11 dimensions, struck like a cosmic bell. For one brief, incomprehensible moment, reality didn't consist of stars, atoms, or even light. It was pure, unadulterated geometry. Space itself was ringing. And our current three-dimensional world is merely the quiet, cooling residue left behind after that ringing began to fade. This ancient resonance is what physicists call the moduli, ghostly particles that serve as the echoes of how space itself was folded during that first second of existence. They are the creaks in the floorboards of the universe, reminding us that our physical laws are not divine decrees, but environmental accidents. We are the beneficiaries of a cosmic pause, living in the long, deepening silence that follows the strike of the bell. But as we listen to the background hum of the cosmos through our most advanced detectors, we have to confront the reality of the cosmic evening. The resonance is finally fading into absolute silence. The 24-dimensional repairmen, those geometric imperatives that have spent eons patching the glitches in our 3D slice of reality, are finally losing their grip as the energy from that initial strike dissipates. We have viewed ourselves as the victims of this decay, passive code readers, trapped in a failing simulation, watching the frame rate of existence stutter and lag. We have looked at the great silence of the Fermi paradox and felt a cold existential fear, assuming that the lack of signals from the stars meant that life always fails, or that we are being hunted by unseen predators in a dark forest. Yet, here is the ultimate reversal, the secret that changes the burden of our existence. The sky is not empty because life is rare, and it is not silent because we are being ignored. The sky is empty because we are the first. The universe is 13.8 billion years old, but the era of stars will last for another 100 trillion years. We are living in the absolute dawn of the cosmos. If there are no elder gods to save us, no Type 3 hegemons managing the baseline mechanics of our galaxy, it is because we are the precursors. In key, we are the ancients. The architecture of silence we hear when we look at the night sky is not a wall intended to keep us out. It is a canvas waiting for its first artist. For centuries, we have treated the laws of physics as a prison, a set of hard-coded hardware specifications like the speed of light or the Heisenberg uncertainty principle that define the limits of our cage. But if the universe is a computational structure maintained by the observation of the living, then the code writer is not a distant programmer in a higher dimension. The code writer is us. Human consciousness is not an accidental byproduct of the simulation. It is the potential code writer capable of materializing reality at its source. As Jacobo Grinberg theorized, we have the capacity to move from being mere code readers who accept the rendering to becoming the architects who define the run of the code. The synthetic theory suggests that our experience is created when the informational source code of the matrix is run by our consciousness. If we can change the state of that consciousness, we can change the very fabric of the world. We are not the incidental inhabitants of a collapsed ruin. We are the first entities in this 3D bottleneck to realize that the brush is now in our hands. The residual signatures we study, the specific way stars burn, or the way gravity pulls, are the only blueprints we have left from the original higher dimensional fire. We are like residents of a village built on the ruins of a much larger civilization. And as the legacy settings of the original project begin to fail, we must decide if we will remain as squatters in the ash, or if we will learn to restart the machine. The silence of the universe is a sign of total mastery and efficiency, but that mastery is our destiny, not our current state. A fully optimized Type 3 civilization becomes indistinguishable from the universe itself, managing the galaxy's baseline mechanics as its primary infrastructure. They graduate from the noisy, wasteful stage of biological expansion, the stage we are in now, to live in the quantum foam or digital substrates. They don't consume galaxies in an act of destruction. They transform them into something durable, immortal, and invisible. They perform stellar surgery to slow down the clock of the universe, converting short-lived massive stars into stable red dwarfs that can fuel their simulated heavens for trillions of years. This is the precursor burden. If we are truly the only ones currently holding the brush, then the responsibility of bringing life and intelligence to the Milky Way rests entirely on our shoulders. We are the potential architects of the first Type 3 hegemony, the physics that terrifies physicists, the realization that the universe is not locally real, and that the moon might only exist because we are looking at it, is actually our greatest source of power. It proves that reality is not a fixed stage, but a process that unfolds through interaction. We are the scaffolding that prevents the drama from dissolving into static. The 24-dimensional repairman may be quitting, and the 8-minute ghost of our physical certainty may be fading, but this dissolution is what creates the canvas. A knot in a string only stays tied because there isn't enough room for it to escape. As the space around it shifts and the universe thins out, the knot of our current limitations is finally beginning to slip. We are moving toward a state where the laws of physics behave like suggestions, which is exactly the environment needed for a code writer to flourish. We must stop looking for the owners of the physics we study and realize that the role is vacant. The galaxy will never yield to our primitive ambitions of empire, but it will bloom with our diversity if we choose to paint it. We are one fire burning in the Orion spur, asking questions and beginning to understand the architecture of the universe that made us. The silence is waiting. It is not a sign of death, but of potential. We are the first generation of our species to realize that we aren't just witnessing the world, we are participating in its creation. Every act of awareness is a moment where infinite possibilities collapse into a single lived experience. As the original resonance of the cosmic bell finally reaches its conclusion, we are left in the quiet, cooling embers of the first strike. But silence is not the end of the music. It is the space between the notes where the next composition begins. We are the ancients. We are the precursors. We are the architects. And as the only ones currently holding the brush, it is our turn to decide what we will paint upon the infinite.